you can apply it to anywhere. Zero field splitting is again, it's related to more than one electron, and there are different things are also involved. I will tell about those things. Okay, so before going into the detail of Kramer degeneracy, so let me tell you about what is Kramer's rule. Kramer's rule says that if an ion has an odd number of electrons, the degeneracy of each level or every level must remain at least twofold degenerate in the absence of magnetic field. So you need to remember three important things about Kramer degeneracy. First of all, it has to have an odd number of electrons. Never ever use the term Kramer degeneracy for even number of electrons. Very careful. Then absence of magnetic field. Okay, and you don't have to have I mean more than one electron or less, because it's only the odd number. It never says how many number of electron. If you have even one electron, so you can have a Kramer degeneracy there. Okay, just let me move towards the zero field splitting. Zero field splitting is a very complicated term, and it depends on many different things. I will not going to discuss about the how the zero field splitting happen, because in order to know those things you need to have some idea of quantum mechanics, and without those things it is very difficult to explain in a simple manner zero field splitting. Okay, I don't want to cheat you guys. Anyway, so there are one important thing is that you need to have more than one unpaired electron for zero field splitting. Now, what are the main reasons of zero field splitting? So there are two important reasons. Number one is dipole-dipole interaction, and this is mainly important for organic radicals. So in biradical, diradical, triradical systems, organic systems, there these dipole-dipole interactions are more effective, and because of that you get a zero field splitting. But for inorganic complexes like transition metal complexes, dipole-dipole interaction term is very small, and zero field splitting mainly depends on spin orbit coupling in case of transition metal complex. Okay, now zero field splitting include two important things, usually described in terms of two things. This is known as D and E. D is the axial zero field splitting and E is the rhombic zero field splitting. Please keep remember this, because I need to use in my following slides. Zero field splitting contains two important things: axial zero field splitting, which is represented by D, and rhombic zero field splitting, which is represented by E. Now let us consider a situation where you do not have any zero field splitting. Okay, let us consider S equal to 1 system. That means we are considering even number of electrons, 2 electrons. Now for 2 electron, total S equal to 1, you have 3 ms level, plus 1 0 minus 1, and in the absence of magnetic field these three levels remain degenerate. So after you apply magnetic field, these levels get splitted, so I get three different levels: minus 1 0, plus 1, and if you apply selection rule for the EPR, you should get two transition from minus 1 to 0 and 0 to plus 1. But then if you see the energy is same. That means you will get only single peak. Okay, so this is without the involvement of any zero field splitting. Now let us introduce zero fill splitting. So as I said, there are two terms are included in zero fill splitting, E and D term. So let me first introduce the D term. So when you introduce the D term, again there are two D terms. There is something called positive D and there is something called negative D. This positive D is your, usually we call it axial, sorry, this is people usually call it a plane anisotropy, and the negative one is known as axial anisotropy. Anyway, I don't want to confuse more, but I mean, just think that there are two D term, positive D term and negative D term. Now what is the effect of that? If you have a positive D term, the lower level remains 0 and upper level goes to +1 and -1/2. And if you have a negative D, the +1 will go down and -1 will also go down, 0 will remain intact. Now many video I have seen, and I was shocked that people are telling this +1 and -1 term as Kramer doublet. Not at all. These are not a Kramer doublet. Let me repeat again. These are not a Kramer doublet. These levels can be easily splitted, or you can remove the degeneracy even without the application of magnetic field. Now how to do that? So as I said, there are two important term in zero field splitting, D and E. So now if you include E, so you can see that after the inclusion of E term, the upper level gets splitted. So you'll have two different transitions. So you have two different levels from the upper level. So basically the triplet term which you have +1 0 -1, if we include both D and E, which we collectively call zero field splitting, you can split them into three different energy levels. That means these are all non-degenerate levels. Fine. Now this is the reason why I was telling that these two levels are not a Kramer doublet, because in Kramer case, even after the inclusion of the E term, the degeneracy remains. You cannot split them. That is the power of Kramer. Okay, now what is the benefit, or what is the gain by using D and E? Okay, now see, we initially discuss without zero field splitting and we got only one peak. Now just look at this diagram. Now here I have considered only positive D. Okay, now if you apply positive D, the 0 will remain in its own place and the +1 and -1 will go up. Now again, using the selection rule, you can have two different transition, 0 to +1, 0 to -1. So now what is the benefit? So what you get by inclusion of the zero field splitting term, there was only one signal initially. Now you start to get two signal. This one also you can represent this way. In most of the books you will get this diagram, although the upper one also valid. So this is usually you will get in the books. So here you can say two different again, this +1 goes below the 0, so you can have from -1 to 0 transition, and also from 0 to 1 transition based on selection rule. So the basic important thing to learn is that after you include the zero field splitting term into your energetics, you starts to get more number of peaks. Now let us look at an odd number of system. Now have taken here s equal to 3 by 2. That means 3 unpaired electron. So total spin is 3 by 2. Now for this you can have 4 different ms level, plus of, minus of, plus 3 by 2, minus 3 by 2. In the absence of the zero field splitting, they all remain degenerate. But then when you include zero field splitting, what you see, this 4 level gets splitted. Here also you can include, you can use both positive and negative d. Here I have used positive d, that's why the plus half and minus 1 goes, plus half and minus half goes down, and plus 3 by 2 and minus 3 by 2 goes up. But the interesting thing is that here I can use the term called Kramer's degeneracy, because whatever I do, whatever the distortion I do, whatever E term I do, even after inclusion of the I term, I cannot split these two energy levels. So this is the power of Kramer theorem. So you can use the Kramer theorem only in case of odd number of electron. So as I showed in my earlier slide, when you have s equal to 1, after the inclusion of the E term, which is called rhombic zero field splitting term, the plus 1 and minus 1 level you can split. The degeneracy you can destroy, but here it is impossible. So you cannot split in the absence of magnetic field. Even after the inclusion of the E term, you cannot split plus half and minus half, or plus 3 by 2 and minus 3 by 2. This is the reason why the Kramer says that in the absence of the magnetic field, if you have an odd number of electron, the levels will remain at least doublet. This is true for s equal to half also. So if you have s equal to half also, you can have a doubly degeneracy. So it is nothing to do with the zero field splitting. Okay, so I hope you guys will never ever use zero field, you will never use the Kramer degeneracy when you use the for even number of electron. That is completely wrong. That will tell you that you have no idea of your EPR. Okay guys, so if you want to know more about zero field splitting, although I'll make some videos, but let me tell you that these are a little bit complicated term in the sense that you need to know about quantum mechanics to really understand the what is the origin of zero field splitting. So as I said, that dipole-dipole interaction and spin orbit coupling are responsible for the zero field splitting, but how? So if you want to know about those things, just message me so that I can prepare for it, because these are a little bit complicated terms. So if you, in the next video I will solve some of the problems related to EPR. So thank you guys. So I'll be happy to answer any question, any query if you guys have. If you guys see any videos, if you do not understand, I'll be ready to answer those questions. Thank you.